Okay, so welcome you all. The plan right away is we're going to be looking at the quiz, and then we'll look at the exam. So we're going to start at, I want to get that over with. I always like to get the past over with, and then we can move to the present. So the past was the exam. I could do the past right away, but the quiz is really fresh in your mind since you just finished it. So I like to start with that one. But I always start, as always, are there any questions about anything? Are there any questions about anything before I move on? Okay, let's take a look and let us go to the quiz. And let's do it. Okay, so here's your quiz. And this quiz, unlike the others, I only put one question on it. And I did that because really there's one main thing to do, and that is normal distribution. And I could ask you the three main things or the few main things I wanted to ask you about any of it. So the idea here is we are told that the amount of time Americans spend on their smartphones each day is normally distributed with mean 5.4 hours and standard deviation 1.7 hours. So the first thing I like to do, and I strongly recommend you do it too, one thing is, if you get everything else wrong, at least I'll give you points for this. And that is write down the distribution. So we have x tilde n for normal. And then if you remember, the mean was 5.4 and the standard deviation was 1.7. So 5.4 comma 1.7. So that's the first thing, is it's always a good idea to write down the distribution, especially because everything changes today. We're not just going to have x anymore, we're going to have other things. So it's a really good idea, and I'm going to enforce it for this next chapter. You have to do this. I'm not going to enforce it for chapter 6, but for chapter 7, you have to. Okay, and for now on, basically. Any questions so far? Just to write that down. Okay, then the question is, suppose that an American is randomly selected. What is the probability the person spends between 5 and 6 hours on their smartphone? Okay, so we want, let me scroll here. For part A, we want the probability that 5 is less than x is less than 6. Any questions on that's what we want? Okay, and I want to mention something. Life is a little easier with continuous distributions. It doesn't matter whether you have less than or equal to. It's the same thing because the probability of any exact value is always 0 anyway. So you don't have to worry about including or not including the endpoint. So that just makes life easier for us. And since I'm typing it, it's a lot easier to type a less than a less than or equal to sign. Any questions? Any questions so far? Okay, so now we need our calculator. You can't do this in your head. That's never going to happen. You're not going to do it on paper either. We have to have a calculator. And the calculator we're going to be using is normal probability calculator. By the way, that's the main calculator for both chapter 6 and chapter 7, this week's stuff. So I'm going to click on that. And our low, we want the probability that we're between 5 and 6. 5 for the low, 6 for the high. The mean was 5.4. And the standard deviation was 1.7. And I hit calculate. And there we go. And by the way, the last thing I would care about is that many decimals. No one in their right mind would ever use that many decimals. For the homework, for the online homework, do whatever they ask for. It's usually 4. For the quiz, as long as you're showing work, I'm happy as long as you get it right. So if you do 2 decimals, that's fine. If you do 4 decimals, that's fine. It's going to copy 4. And I can paste the 4 in. Any questions at all on part A? Okay, let's go to part B. For part B, let's scroll up. Suppose that an American is randomly selected. What is the probability that the person spends less than 3 hours on their smartphone? Okay, so we want the probability that they spend less than 3 hours. So we want the probability that X is less than 3. Any questions so far? Okay, so now I go back to my calculator. And if X is less than 3, what is the low and what is the high? What do you think? If X is less than 3, what's the low, what's the high? You could, yeah, the high is definitely 3. And I would accept either 0 or technically negative 9999 because I said it was normally distributed, which means it goes down forever. Is that clear? Okay, we need to get rid of P because we have to leave one blank and we don't know the probability. The mean and standard deviation have not changed. And I hit calculate. And I get 0.0790. I'll just go 4 decimals. Any questions at all on part B? Okay, let's get to part C. Part C is what is the third quartile for the time Americans spend on their smartphone? Okay. Yeah, as I mentioned, again, you guys are debating about the negative 9999 and the 0. I would accept either. So if you take it on what is practical, 0 is probably better. If you take it on what's written, negative 9999 is better. And that's why I have to accept either. Because if it's truly normal, you could have negatives. But it's silly to even say it's truly normal because you can't have less than 0 on your smartphone. Okay. So again, I would accept either answer. You're close. It's not that much different either way. I think it's good for 2 decimal places if I remember right. Okay. But the most important thing is write down your work. Don't just write down the answer. Okay. That's why I put down here in symbols. You got to write it in symbols because then even if you get it wrong, even if you put in 1 by mistake, but you had, you know, the right probability written up there, I can give you some points. So it's very important to tell me what you're doing, especially because if you make a little mistake, then I can give you lots of partial credit. But if all you have is a wrong number, then, and no work, nothing else shown, I can't give you lots of partial credit. Okay, so that's important. All right, so part C. What is the third quartile? So how is this different than A and B? Like there's some big differences here, or one big difference. It's a range. B was a range. A was a range, actually. Yeah, we don't know the high. What do we know? Yeah, here we know the probability, and we want to find the high. Okay, so we know the probability, we want to find the high, whereas on parts A and B, we knew the range, and we wanted to find the probability. So the third quartile, let's go over here. What is the probability if I know the third quartile? What is the area to the left? Yeah, 0.75 if we look left. You can look right and go 0.25, but I think 0.75 is just easier to remember, 75th percentile. All right. This time what we don't know is the high. That's what we want to find out. Okay, the low technically is negative 0.9999. So now we just hit calculate. Same standard deviation, same mean. So those don't change. And the third quartile is about 6.5466, more decimals than you'd ever care about. And what's given in the calculator is way more than you'd ever care. So the third quartile, let's write this down. That's the probability that X is less than Q1 is equal to 0.75. And then I'm going to write, so Q1 is equal to 6.5466. That's kind of how you show work. So I can give you credit, sorry, Q3, not Q1. So I can give you credit even if you make a mistake. I can still give you some credit. Okay, any questions? Any questions at all on the quiz? Any questions? Okay, if there's no questions on the quiz, I think I want to jump into talking about the exam. And let's pop in the exam and we'll do it. But I want to mention something. The exam, again, was worth a lot, but if you didn't do well, it doesn't mean that you can't do well on the next exam. But if you don't change the way you do things and you didn't do well, you probably won't do well on the next exam. So change the way you do things could be spend more time. So again, I have no idea how much time you're spending because I'm not a mind reader. But if you did not do well in the exam, then there's a good chance that you need to spend some more hours in this class and practicing. If you did do well, smile and do it again. You know what I mean? If it ain't broke, don't fix it. And I'll probably be fine on the next exam. But I'm here to help. The other thing is you can ask questions whenever you want. Just ask. You could ask during the webinar. You can ask outside. You can pop in the Q&A in the little Q&A form that I've got. There's lots of ways of asking questions. You can even email me. Even better is we have tutors. So you can go to Anna, and Anna's the embedded tutor, and she can help lots. You can also go to other tutors too. Anna's our key tutor though. And there's lots of people that can help you out. But if you don't put in the time and the effort, then it won't go well for you. I do want to make one more note, not that I'm going to encourage it, but we're in weird times, and normally you only have I think you have one more week to drop the class, or you get an or you get an F no matter what if you don't do any work. But they've changed things. You can decide at the last minute to drop the class if you want. You can also move to pass no pass at the last minute. You're allowed to do that. So there's a lot of things you can do. If you go to pass no pass, make sure you talk to a counselor first though, so that wherever you want to transfer your university is going to be okay with it. So that's something I can't help you because I don't know every university's rules. But again, you can stay in the class for a very long time, and at the very end, you can decide. Okay, hopefully, even better is you'll put in the extra work, and then of course you're gonna not drop the class because you're gonna be doing great. Okay, I'm here to help. Anna's here to help, and so is Kevin, by the way. Kevin's the embedded tutor for the other statistics class, for Wynn's class, and he obviously knows statistics because he's her embedded tutor. So they're every day, they're there, not every hour of every day, but a bunch of hours. Okay, and I'm also around after class for office hours, and I'm also around at 11:10 or 11:15 for office hours on Monday, Wednesday, Friday. Okay, and I check email a lot. Any questions before I start talking about it? Okay, question number one. If you don't know how to do question number one, you got other issues. What is your name? Hopefully y'all know your names. So that was an easy one. Everyone got that right. But it was basically signing that you won't cheat. That's the important thing. Okay. And what I do, again, this is Proctorio, and I'll let you know how I'm using Proctorio. Is that if I have any suspicions. So if the answer to your to a problem that you did doesn't really fit you, then I'm going to watch the video. If everything you did seems to fit your character and what we've been doing in class and your quizzes and all that, I don't even bother looking at the video. That's kind of how I decide. But if all of a sudden you start talking at a PhD high level statistics, that means you probably asked someone to do your work, and then I'll find that you did that. But if you talk like yourself, then it's pretty obvious that you didn't cheat, and that's the main thing. Okay, let's go through these, and I want to see how you guys do. Okay. Okay, and by the way, I do like to put in your names, so that's just for fun. That's the only reason I do that. Maybe it made a couple of you smile. That's all I want. So true or false? Erez wants to study the birds, mergansers, geese, and gulls floating on Lake Tahoe. To obtain a stratified sample with sample size 60, she should track 20 of each. Okay. So I don't want to just, I want to put in the chat box, not true or false. Sorry about that. But you know what? Again, I don't know. It's one thing I don't do is I don't check gender. It's a name I hadn't heard before, so I apologize. You have a unique name. But that shouldn't matter in terms of whether it's true or false. This wasn't about gender. This was about, is this true? And if this is true, why is it true? And if this is false, why is it false? So what do y'all think? Okay. So again, if you think it's false, why do you think it's false? What's wrong with it? That's not necessarily cluster. It doesn't really talk anything about like grabbing a specific group area and looking at all of that be cluster. Yeah, that's the issue, is that it's not that you should track the same number of each. It's that you should track a proportionate number of each. So you should, whatever percent of mergansers there are in Lake Tahoe, you multiply that by 60, and that's how many mergansers you should track. You take the percent of geese in Lake Tahoe, you multiply by 60, and that's the number of geese. And the same thing, you take the number of gulls and multiply by 60, and that's the number of gulls you should survey. And they're not going to be, it's not going to be the same number. It's not 20 of each. Okay. And again, you don't have to know anything about Lake Tahoe. It's not divided evenly. It's divided proportionately to be able to do stratified sampling. Any questions at all on the first one? Okay, let's move to the second one. Okay, with the box plot, it's easier to see the mean than the median. Okay, so true or false, and why? Yeah, and how come? Yeah, the median is one. The box plot shows a 5-point summary, and the median is one of the 5-point summary numbers, and the mean is not. So the mean is just right there, and the mean is not right there. Any questions on that? So this one's false. Okay. Problem 4. A histogram is better for larger data sets, while a stem and leaf plot is better if you want to show the individual data values. So what do you think? None of these are meant to be trick questions, by the way. They're meant to be, do you understand what's going on here? Okay, this is true. And the reason is because it is, I know it sounds weird. The reason is stem and leaves don't work for very large data sets because you'd have to fit too many numbers on the chart, and there's not enough room. If you had 1 million numbers, you can't do it. Okay. Whereas the histogram doesn't show individual data values, so and the stem and leaf does. So that's the reason. That's true. Okay, the probability of A and B cannot be larger than the probability of A given B. True or false, and why? I think this is hard for most of you. Hard means that it didn't have a high percentage of correct answers. Okay, so this one has to do with the formula. So we had an equation, and I'll say it as I put in the chat box. I'll say it because on video you can only hear what I say, and the chat box is, then you can see it if you're here. But the probability of A given and A given B, there's two ways of looking at it, is equal to the probability of A and B divided by the probability of B. I don't know if you remember that formula, but that formula happened. Well, if you take a number and divide it by probability, the probability is going to be 1 or less, usually smaller than 1. You take a number and divide by a number smaller than 1, you get a bigger number. So the probability of A given B is going to be the bigger number. You can't have the probability of A and B be larger because to find probability of A given B, you take A and B and divide by a number less than 1, less than or equal to 1. So that's why that's true. Any questions? Again, this was hard for most of you. Okay, question 6. If the expected value for the number of pets that American families own is 1.9, then when interpreting this number, you must round to 2, since it does not make sense to have 1.9 pets. So what do you think? Okay, yeah, this one's false because there's a key word in the expected value interpretation. What's the key word that's going to make this one false? Remember, there were like 4 keywords I told you had to have in your interpretation? One of them makes this false. Anyone know? I don't see y'all jumping in. Okay. Not close to. It's one of the others. Good try, though. Average. Average. And if you're talking about averages, averages are not, they do not have to be a possible value. Okay. Fractionals are fine when you have averages. Okay. The average number of children that American women have, okay, or is about 1.8 right now. Okay. So now, should we say you have to round to 2 because it doesn't make any sense to have 1.8 children? Or does it make sense to say that the expected value, which is the average, is 1.8? What do you think? Any thoughts? I don't see y'all jumping in or seem quiet. I don't see you telling me. All right, so maybe I should talk about it then. Okay, so the expected value for again, for a number of babies American women have, just giving you another example because it's going to be more meaningful, is 1.8. Okay, that tells you something. That tells you something very different than 2. If the expected value is 1.8, what that means is that we're below the number at which you end up sustaining your society. So if you want to sustain your society and you have an expected value of 1.8 for the number of births, then you need immigration, for example. There's a lot you can say, whereas if you round to 2, you would never say that you're not sustaining your society. Any questions on kind of the real life idea? Okay, now this is about pets, but it's not really any different. You know, it's just you can have an average of 1.9 pets per person. So that's why this is true. I'm saying it because most of you got this wrong. That's why I'm spending some extra time on this. Okay. If X follows a uniform distribution between 3 and 8, probability of X equals 5 equals probability X equals 10. Let me ask you, if X is a uniform distribution between 3 and 8, what's the probability X equals 10? It's 0, exactly. What's the probability that X equals 5? It's also 0. Uniform distributions are continuous distributions. The probability that X equals any value is always 0. So is it true that 0 equals 0? Yeah. Okay, so that's why this is true, because this just says 0 equals 0. Any questions at all on question 7? Okay, question 8. By the way, you'll notice these are 3 points each. Later, they become a lot more points because this is just a quick, do you know the word kind of problem instead of do a whole lot of stuff. Okay, Kamala is interested in the proportion of college students who are living all alone during these difficult times and asked 85 college students the appropriate survey question. Then the variable for this survey is, okay, I'm not going to ask you which is it. What I'm going to ask you right now is, see if you can type in the chat box. What would the survey question be? What are you going to ask this college student? You're going to ask a whole bunch of college students something. What are you going to ask the college students? What question would you ask them? Yeah, you say, are you living alone? And what would an answer to that question be? So I'll let you pop in the chat box. I'm going to ask you the question. Are you living alone? See if you can type in the chat box. I want to see some answers. Yeah, so the question, are you living alone during the quarantine? And let's see if you can type in the answer. Okay. All right, and what I'm seeing are no and yes and no and no and yes. Okay, those are not numbers. Is that clear? So the answer to the survey question is not a number. And not a number is which of the 3 choices? Yeah, it's qualitative. So question number 8's answer is qualitative, because the survey question is, are you living alone during this time? And people are going to say yes or no, and that's qualitative. Any questions on this? Okay, so be very careful about whether you're talking about the survey question, which is what we're talking about when talking about the variable, versus what is it you're interested in finding out, which is the proportion of all college students, not the survey question, not the variable. Okay, which statistic is not strongly affected by outliers? The median, the mean, or the standard deviation? This came from 4 weeks ago or so. It's been a while. I think this was day 1. Might have been day 2. I don't remember. which is not strongly affected by outliers. Yeah, the median is not strongly affected by outliers, because let's say you have 500 people and you throw one super outlier as an extra, the middle's not going to change much, but the mean and standard deviation will. Okay, now let's take some more. The distribution of the variable x is shown above. The standard deviation could be, okay, 0.5, 0.05, 1.5, 61, or 60. What could be the standard deviation? Yeah, 0.5. Let's look at the reason. So standard deviation means that if you move left and right that amount, you're going to cover most, kind of majority, but not like almost all of it, but the majority of the data. So if you only move 0.05, that's a tiny, tiny, tiny bit from 60. You see that? You're not going to get the majority of the data if you move a tiny bit from 60. If you move 1.5, that would be going from 58.5 to 61.5, and that's basically everything. Do you see that? And one standard deviation isn't everything. It's around 68% of the data. On the other hand, if you go 61 away, then you really have everything. And same thing with 60 away, you have everything. But 0.5, that would be 59.5 to 60.5. And that looks like it is around, the majority, but not the overwhelming majority. And that's why 0.5. Any questions on this, on question 10? Okay, so those were the idea questions. Now it's time to go the do it questions. And I want to show you something. All these other ones are 3 points each. Now we're going to do the more involved questions, and they're worth a lot more points. Okay, so if you make one mistake, if you make a mistake or two on the first 10, not that big a deal. The other ones are a bigger deal because they're more points. Because now you have to do a whole lot of stuff. Okay. I'm going to weigh 10 newborn kittens for a research project. The data in ounces are shown below. Here we go. Use z-scores to determine the outliers. And then I gave you a hint, copy and paste into the appropriate calculator. So I'm just going to copy. This way we don't have to type it over and over again. One reason, by the way, where this is actually easier than a handheld calculator, which you can't copy and paste. And I have to go to the right calculator. Which is the calculator I want? Somewhere between 1 and 24. And it's not going to be one of the higher numbers because we haven't gotten to those yet. Which calculator do we need? Yeah, number 2. So I'm going to get number 2. And I am going to pop these in. I put commas in the middle, so everything's ready. Just copy and paste. Notice this was a sample. It's a bunch of kittens that we looked at. So this is the sample standard deviation, not the population. And I hit calculate. Okay. One of my favorite numbers is the mean. Do you know why it's one of my favorites? None of you recognize it? Yeah, it's around pi. 3.14. Standard deviation. 0.8765. Another easy one. By the way, that was just random. I didn't plan that at all. But hey, might as well have nice numbers. So it counts down from 8. Okay, none of the other stuff we need. Sound good? Any questions on that so far? Okay, by the way, I could go back to links from calculator if I want. Let me show you two ways of doing this. I can go z-score. So I think that's what I want to look at. Yep. And our x.
How did you change calculator again? Because I was struggling with that in the test.
So there was a link. This is not what I expected you to do, but I figured I'd show you a quick, easy way of doing it. And this was, I don't know if I can go back to it, because now I've gone back. I think I can only do it once. So this was just a tricky way. But, and maybe actually I know, right, I know someone was struggling. I don't like to mention names unless you tell me your name, because some people like to stay private, but I know one person was struggling about finding the calculator, but I know other people found the calculator. And here's something that, and that's the calculator, the scientific calculator. I have no idea, because I don't have access to it because I'm the instructor and I don't have access to Proctorio. But I set the settings that you have access to the scientific calculator. Can any of you that were able to get it, and most of you were able to find the scientific calculator, can you explain how you did that? Because I have no idea, actually, because I can't test it.
What I did on Proctorio, it was on the left side where it said like Proctorio tools or exam tools, something kind of like that. It said on the left, and one of the buttons, it was a calculator, and I just used that.
Okay, so do you hear that? Those of you who had trouble finding the calculator, it's not one I can show you because I don't have access to it. Only students do. Okay. Yeah, the back arrow, I'm a little afraid of the back arrow because the back arrow might get rid of your work. So I'm worried about the back arrow. So I'm just going to show you this calculator just for fun, and then we can do it by hand too. X. Again, what we want to do, by the way, is we want to look at the lows and the highs. We had 1.1 was our minimum. And notice that if I put in 1.1, and the mean was pi, 3.14, close to pi. Standard deviation was 0.8765. And I can calculate it. And we get negative 2.3274. Does that mean 1.1 is an outlier? Yes or no? Negative 2.3 is good enough? Yeah, this one's a yes. Okay. So 1.1 has a z equals negative 2.3. 1 decimal is all we need, which importantly is less than negative 2. Any questions on that? Okay. And that's our bound for an outlier. Some of you thought 3 and negative 3, that's for extreme outliers, but the general outliers, negative 2 and 2 are the bounds. So a few of you are confused about that. But but if you explained yourself, I didn't take as many points off, just let you know that. If you didn't explain yourself and you said no outliers and didn't do any work, that's bad. Okay, so is an outlier. All right, now let's go to the next lowest. We got to keep going until we don't get an outlier. The next lowest is 1.2. So let's go back to the calculator. Make that 1.1, 1.2. I got to kill the z-score here. Now let's do it. And we have negative 2.2. So 1.2 has a z-score of negative 2.2, which is also less than negative 2. So is an outlier. All right, let's go to the next lowest. So the next lowest is 2.9. Again, you just kind of skim through until you find the next lowest. So let's go and put 2.9 in. Okay, what do we say about 2.9? Yeah, not an outlier. Our z-score, I'm going to go 1 decimal, is negative 0.3. So 2.9 has a z equal negative 0.3, which is greater than negative 2. So is not an outlier. So we've now found the two outliers that are below the mean. Now we got to test above the mean. So let's find the maximum. The maximum value is 4.2. So let's plug in 4.2. Erase the z-score. And I see 1.2. One 1.2 has a z. 4.2 has a z equal 1.2, which is less than 2. And that means it's not an outlier. So therefore, 1.1 and 1.2 are the only outliers. Okay, and I just want to make sure I answer the question. Always good to do that. Question is, write down each of the outliers and how you determine their outliers. Any questions about this problem? Okay, let's go to number 12. According to Gallup poll, 61% of Americans say that the upper income group pays too little in taxes. If 30 randomly selected Americans are surveyed, what's the probability that at least 19 of them say that the upper income group pays too little in taxes? Okay, you can use a calculator from below, but explain how you arrived at the answer. All right, so what kind of problem is this? And by the way, in this class, that's often the hardest part about the whole class, is deciding what to do, what kind of problem. So what is this? Yeah, this is a binomial. So I'm going to go to my calculator, and I'm going to go to binomial probability. And I need the low, the high, et cetera, et cetera. So remember what we have here. Find it. We wanted at least 19. So that goes from 19, and there were 30 that were surveyed out of 30. So it goes from 19 to 30, and our P is 0.61. And I hit calculate, and I get 0.4758. So I used the binomial distribution with low 19, high 30, trials 30, and P equals 0.61, and found the probability to be 0.4758. Okay, just want to let you know if I go too fast, let me know. Ask me questions. That's the important thing. Because if I go slow, then we're going to spend the whole time just doing this. And I do want to talk about the chapter 7 a bit. We also have a lot of time on Thursday to talk about chapter 7. We have all of Thursday. So I'm going to just start chapter 7 today. Any questions on this problem here, question 12? Okay, question 13. Courtney is planning to put a bid on the new South Lake Tahoe passive hydroelectric energy project. It will cost her $24,000 for the planning and preparation associated with the bid. If Courtney is awarded the bid, she'll make a total profit. And I want to mention this is a profit, okay, not revenue, but profit of $100,000. Courtney has determined that there is a 28% chance that she'll be awarded the bid. So we want to write down a probability distribution table for this situation. Go through the table first. Scroll to the bottom. And part A. I'm going to make a table. We're going to have X and P of X. That's how you always have tables when it's probability distribution. There are only two choices here. That's why I have three columns, by the way. So she could get the bid, which is a profit of 100,000, because that's given. Or she can not get the bid. If she doesn't get the bid, what's her profit? If she doesn't get awarded the bid, yeah, negative 24,000. Okay. The probability of getting the bid was 0.28. The probability of not getting the bid is 1 minus that, 0.72. Any questions on that? Okay, that's part A. Let's go to part B. Part B, or number 2, says find the expected value in the standard deviation for this situation. All right, which calculator do I need? What number? Somewhere between 1 and 17? Yeah, number 5, expected value and standard deviation. I tried to make labels obvious. So it says find the expected value and standard deviation, use the expected value and standard deviation calculator. Okay, and now we just put in our table that we had. So we had X was 100,000, and the second X was negative 28,000. The probability of 100,000 was negative 24, wasn't it? Let me see. 24,000. Let me make sure I got that right in here. Yeah. Probability of getting the bid was 0.28. Probability of not getting the bid was 0.72. And I hit calculate. I want to mention something because I did get one person who said that the calculator didn't work for them. My best guess, I can't know for sure, is you put a comma right there. If you put a comma, it's going to tell you that it's not a number, because comma is not a number. So I just want to let you know with these calculators, you can't use commas. Okay, it's a common mistake, and don't do it. Don't make that mistake, because it'll drive you crazy. Yeah, so just don't put commas in any number. So all you're allowed to put is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, dot, and negative. Those are the only things allowed for numbers. Okay, and our expected value was 10,720. So for part B, I have to do over here. There we go. Expected value is 10,000. Let me write EV for expected value. 10,720. And sigma, our standard deviation, was equal to I'm going to go dollars and cents. Probably dollars is fine, though. Nobody cares about pennies. But I can go with dollars and round up to a 6. Nobody cares about pennies when you talk about a $100,000 bid. Okay, and I'll even pop in a dollar sign, because that's what we're looking at. Any questions at all on part B? Okay, part C. If I want to mention something, when I warn you about something when I'm giving the webinar, it's going to happen. You must have the keywords in there or I took off points, period. I promised I would and I did for those who didn't have it. And those who did have it, then you got lots of points. Some of you left out one of the words. I noticed that too. And it was different ones depending on which person it was. But let me write it out and I'll talk about the words. So we can say that if this was Courtney, I think. Yep, Courtney. If Courtney makes many bids, many is one of the words, on similar projects. We'll assume Courtney's in this business and that's what she does all the time. Every month she might make another bid, okay? And we're gonna assume that it's always the same kind of project with the same probabilities and X's. Then it is likely, that's another keyword, is likely, that her average profit per bid will be close to $10,720. Now I can put the comma in because now I'm just typing. Okay, let me do the following. I think I can. Let's see. Does it let me? Yeah. Just to remind you the words I was looking for. So many, likely. By the way, I didn't take out points if you didn't do it in red, but I want to just kind of emphasize that I promised you in the webinar that you had to have those words, and I stuck to my word. Any questions at all on part C? Okay. Question 14. Histogram below shows a frequency of quarterly returns for US companies. The mean was 0.02. Okay. Describe the distribution in the language of statistics. At least two technical terms that were discussed in class. Okay, what is the shape of this curve? We actually had a whole chapter on it that was due on Sunday, but we talked about it in chapter 1 also. That's why I felt okay with it. Or maybe it was chapter 2. I think that's chapter 2. What's the shape of this curve? In one word, and then we'll do other words too. So what's the shape of this curve? Yeah, normal. So let me write down the distribution. And I'm going to write approximately normal. And then I can say a few more things. It's symmetric and unimodal. Those are kind of the words I was looking for. Okay, normal is the biggie, but then I was looking for one more too. And symmetric, unimodal, those are good ones to go with it. Okay, it's not perfectly normal, but it's approximately normal. It does have the little wedges and stuff, but this is about as close as you'll ever get in the real world. Okay, B, if one additional company has a quarterly profit of negative 0.5 is added. Okay, negative 0.5 is way there to the left. Do you see that? Negative 0.2 is already beyond most of the data. Negative 0.5 is very strong outlier. Remember, the standard deviation measures how far the data is away from the mean. If I throw a number that's very far to the left, then are we farther from the mean on average, or are we closer to the mean on average, or neither? What can you say? So is the standard deviation going to go up or down, or is it going to stay the same? if I put a very, very, very far left outlier in. I don't see y'all jumping in, but I'm hoping. Yeah, it's going to go up because now we're adding a very large distance number. If you have a bunch of numbers that are all small, and then you add a number like 1,000, then guess what? The average goes up. And that's what we're talking about. That's what the standard deviation is. So B is the standard deviation. Will go up, will increase. Since negative 0.5 is an extreme outlier. So the average distance from the mean will increase. Any questions on that? Okay, now I want to mention the mean was 0.02. If I add 1,000 additional companies that had a quarterly returns of 0.02, right at the mean, then what will happen with the standard deviation? So if I have a bunch of numbers that might be 1 and 2, and actually more like 0.1 and 0.2 and 0.05 and 0.35, 0.1, 0.1, 0.05, 0.03, 0.02, and then I throw in 1,000 zeros. Will the average go up or down? Or stay the same? Because that's what we're doing. We're adding 1,000 that are 0 from the mean. Are we now closer to the mean or farther? Yeah, we're now closer to the mean because we've now added a whole bunch of 0 distance from the mean. So if you throw a bunch of zeros into a bunch of not positive numbers, the average will go down. So adding a 1,000 numbers that are all 0 from the mean will make the average distance from the mean go down. So the standard deviation will decrease. Any questions on question 14? Okay, let's go to question 15. Table below shows data that was collected to look at alcohol ordered at a bar and gender. Okay. And by the way, hey, we might be opening again soon. We'll see. The governor just said that there's going to be some light opening. So I don't go to bars and order beer, but other people might. Okay. Or hard liquor or wine. I'm not a bar person. Okay, but some of you might be. Okay, A, find the probability of the randomly selected bar patron will order wine. So we're looking at wine. So the first thing I want to do is I want to write it in symbols. Probability of W for wine. I think there's only one word there that starts with a W. So this is a simple probability of wine. So we count how many people ordered wine. That was 290. Out of the total is 1,060. And that's it. 290 over 1,060. Most of you got that right. Then it got harder after there. Find the probability that a randomly selected bar patron will be a woman who orders beer. So that's P of what? Oh, you know what? Sorry, I was wrong. Let's go WI for wine. Woman starts with W also. All right. So a woman who orders beer, what's that the probability? When symbols, what is that? To be a woman who orders beer. Let's see if you can put the chat box. What is that? I don't see y'all typing it at once or saying it. Not looking for the number, I'm just looking for letters. All right, maybe this is tough to decipher, but it's not a trick question. Okay. To be counted, the person has to be a woman and they have to order beer. That's going to be, I'm going to write W-O. And how about B-E? I'm going to use the first two letters. So that's the probability to find the probability the person is a woman who orders beer. That's what we do. And then we look at the table. Where is it? There it is. And there are 220 women who ordered beer out of 1060. Not supposed to be a trick question. It's just, can you read the words and understand what they say? Okay, C. Find the probability a randomly selected bar patron will be a man or order hard liquor. So that's going to be probability of a man or hard liquor. And there's a formula for that. That's a probability of a man and, probability of man plus the probability of hard liquor minus the probability of man and hard liquor. Equals. Okay, first thing is none of these are given. If you don't have any givens, then whatever we have, it's all going to have the same denominator, and that is 1060. So now we just count how many men, how many hard liquor, how many both. And now we go in and we say men, there were 510. Hard liquor, there were 270. So 510 plus 270 minus, and man and hard liquor, 130. And that is, let's see, 270 minus 130 is 140. That's 650 over 1060. Okay, and I told you leave as fractions. D, if a randomly selected male bar patron is selected, find the probability that he will order hard liquor. What's this a probability of? Anyone want to chime in? Let's pop it here. So randomly selected male bar patron is selected. Find the probability that he will order hard liquor. In symbols, what is that? I don't see y'all jumping in, so I might do it. Yeah. So it's the probability of hard liquor. I'm just going to write HA for hard liquor. And this is a given problem. Man. So now we find hard liquor males. That is 130. And then we say that we know the person is a man. And there were 510 men. So 130 over 510. Any questions on that? Okay, last one. Being a man and ordering beer, mutually exclusive, independent, both or neither. So man and ordering beer. So first thing, let's find the probability of man and beer. And that is 280 over 1060. What's important about that number if we're looking at mutually exclusive? Yeah, it's not 0. So they are not mutually exclusive. Okay, then we need to find out whether they're independent or not. So let's find out if the probability of, and there's lots of ways of doing this. How about man given beer? Is that equal to, all right, equal question mark, the probability of a man? So let's do man given beer. So man given beer will be 280 divided by 500. And is that equal to the probability of a man? Probability of man is 510 over 1,060. And if you work that out in the calculator, they are not equal. Okay, they're not equal to. I don't even need a calculator because I know that 280 is more than half of 500. I know 510 is less than half of 1,060. So they can't be the same. So they are dependent. Not independent. Any questions on question 15? Okay, getting it. Question 16. Almost done. A box of whiskers plot shows the age distribution at LTCC. What age is a 35th percentile? Okay, the key is you have to understand how to read a box of whiskers plot. Okay, what percentile is 14? A 14-year-old is what percentile? Yeah, basically 0th percentile because it's the minimum. How about a 17-year-old? What percentile is a 17-year-old? Yeah, that's the 25th percentile. So notice that we want 35th percentile. It's got to be older than 17. How about 26? What percentile is that? What percentile is a 26-year-old? That's not supposed to be too hard, by the way. Just reading a box plot. Yeah, that's the 50th percentile. Okay, and by the way, we want 35th percentile, so 26 years old is too old. 17 years old is not old enough. So I would accept any number in between that's greater than 17 and less than 26. And 35 is a little closer to 25th percentile, but any number is fine. If you said 20 years old, that's fine. But it's not okay to say anything that 17 or lower or higher than, what number was that? Higher than 26. So in particular, how about 20? Since 17 is the 25th. And what was the other number? 26 is the 50th percentile. The definition of median is 50th percentile. That's just a definition. Okay. So it's not any different than the 50th percentile. Does that make sense? Okay. There's some slight issues with some calculation stuff, but very slight. And I'm not going to go there, but it's certainly not going to be 35th. Okay, part B. What is the probability that a randomly selected student will be between 42 and 93? All right, what percentile is 42? '75th percentile. 93 is the maximum. If there's 75% below 42, how much is above 42? 25%. So part B is 25%. So since this is the region above the 75th percentile, there is a 25% probability of being there. Okay, next one. Now we have 14 students are randomly selected. What's the probability that exactly 10 of them will be between 17 and 93? Okay, what kind of problem is this? That's usually the hardest part about this one. What kind of problem is part C? Yeah, this is a binomial problem. And we want to be between 17 and 93. Notice 17 and 93 is everything above the 25th percentile. So our P is 0.75 because there's 75% above 17 to 93. Okay, we want exactly 10. So we're going from 10 to 10 and our trials is 14. So now we go ahead and go to binomial probability. We're going 10 to 10. Our trials was 14. And our P was 0.75. And hit calculate, and there we go. 0.2202. All right, we're almost there. Okay. I think this is the last one, if I remember right. Yep, last real problem. Suppose the air pressure of tires is considered safe is uniformly distributed between 31 and 40 psi. Show your work. Find the probability of randomly selected tires air pressure is between 33 and 37. Okay, so before I even do part A, what I want to do is I want to use the 31 to 47 to think of a rectangle. So a uniform distribution and let me just write X tilde U from 31 to 40. So that's our distribution, is a rectangle with base. What's the base? What's the width of the base? What's the width of the base of the rectangle? Not supposed to be too hard. What's the base of this rectangle? If it's a uniform distribution between 31 and 40. I think I can actually draw a rectangle. Let's see if it'll let me. Yep. There's a rectangle. What's the base? Yeah, backwards actually. 40 minus 31. Does that make sense? Okay, or maybe you're saying 31 to 40, and then that's good, which is equal to 9. So now we know the base times the height is the area. So we know BH equals, we write area, equals BH, which equals, the base is 9 times H. And if we're talking about the whole rectangle, what must the area be for any uniform distribution? 1. So H is equal to 1 over 9. We need that. Okay, for part A, we want to find the probability that we're between 33 and 37. So the probability that X is between 33 and 37, well, that's a base times height also. Now the base is 37 minus 33. And the height is still 1/9. And 37 minus 33 is 4 divided by 9. There's A. Any questions on part A? Okay, part B. Determine the first quartile for safe tires. So we want the probability that X is less than Q1, which we don't know what it is, but what we do know is that probability is 0.25. But that is equal to the base times the height. The base is going to be Q1 minus 31, because the distribution starts at 31. The height is 1 over 9. Put a times there. And now we do algebra. Multiply by 9. So 9 times 25, 9 times 0.25, which, by the way, is equal to, I like to look at it, hey, if I have 9 quarters in my hand, I got $2.25. So 2.25 is equal to Q1 minus 31. And now add 31 to both sides, and you get Q1 is equal to 33.25. Any questions on part B? What do you have height if you know it cancels itself out? Well, okay, remember the area of the rectangle is base times height. Nothing canceled. Okay. So that's why I use the height, and you certainly need it for part B. Do you see that? So since we needed it, might as well just do it first. Yeah. So I always just start out getting the height, because you're always going to need it with uniform distribution, pretty much. Got part C, which is a little different. Part C is a very different kind of problem. Find the mean and standard deviation for safe tires. So the mean is equal to, the formula is a plus b over 2. So it's going to be 31 plus 40 divided by 2. And 31 plus 40 over 2 is 71 over 2, which is 35.5. Any questions on that? Okay, standard deviation. I'll just write SD for standard deviation. That is going to be the square root of b minus a. So that's going to be 40 minus 31 squared divided by 12. That's just a formula, which is equal to, I'm just going to pop it in Google, is the easier. Again, unlike me, you actually get a calculator that's attached to this thing. I don't. If I pop it in, 2.6. I'll go for that. Any questions on that? Okay, we got our mean and standard deviation. Next is use part C to find the z-score for a tire that's inflated at 38. So D, we just take 38, subtract the mean, 35.5, and divide by 2.6. And I'll pop it in my URL calculator. And I get about 0.96. Okay, I don't really care how many decimals you keep, as long as you show your work, I'm happy. Any questions on question 17? Okay, we're almost done. The last question, extra credit. So a couple things. One is what I decided to do is I gave you up to 15 points on the extra credit. Okay, why would you get fewer than 15 points? I mentioned it during the review. Any remember? Remember?
What was the question again?
Why would you get less than 15 points on the extra credit? And the hint is, if you got that, you smiled. And if you didn't smile, there's something wrong with you. Anyone know? Everyone forgot? Because it brought you to 100%. Okay, and we did have a couple that fewer than 15 points and they got to 100%, and that's the highest you can get is 100%, which is a good thing. So that's just a note. I jotted down so I can read it. In terms of things that people wanted to change, one person wanted me to slow down a little bit. Please tell me to slow down if you don't understand what I say during the webinars. So I'll be happy to slow down, but only when you want me to slow down, because we do have a certain amount of material to cover. So that's just a note. I'll be, you got to let me know though. There were 2 people had issues with the project partner idea. I am a strong believer in requiring partners. One wanted random partners. I could do that, but then if you have a friend, you can't work with your friend. You guys want? I mean, we could make that. I could randomly assign you guys partners. Would you all rather have that? Okay. Do you want to let you know for project 2, you don't have to have the same project as project 1, same partners as project 1. You can switch that around. And I did put a project 2 discussion board up in Canvas. So that's a good place to, find partners, especially if your partner dropped or you just hated your partner or whatever, it didn't work out with your partner, whatever it is. Okay, you can change partners. Okay, that is allowed. Somebody wanted a normal calculator. I can't let you have the handheld calculator because Proctorio doesn't know the difference between a handheld calculator and a smartphone. I can't let you use a smartphone. That's the problem with it. So sorry about that. A couple of people wanted answer keys to the practice exam. I don't do an answer key. What I'd rather you do is, if you're not sure about an answer, post on the Q&A board or send me an email or whatever, and then I'll help you with it. But I want you to take it without the answer key, because that's the better practice for a real exam, because you don't get an answer key on the real exam until it's over. So that's why I don't put an answer key, because it's too tempting. Okay, so instead though, feel free to ask me, did I get this right? And then I'll help you. So that's actually a reason why I don't do an answer key. What you should do though, if you want problems with an answer key, is redo the quizzes. And the quizzes, again, are all done during the webinar. So there is an answer key at the webinar. One person wants a longer time for quizzes. It's hard for me to know. If you're all feeling that way, you need to let me know as a group. If it's only one person, that's different. That's hard for me to know because I don't get to see. But it doesn't seem like most people are running out of time. Most people seem to have enough time. Those are the main things that you wanted changed. I'm doing my best is all I can tell you. But make requests. Like I said, if I hear from a lot of people, only one person asks, and they'll change the whole course, I'm a little reluctant because I don't want to ruin it for everyone else who didn't ask. If it was a whole lot of people ask, that's different. So for example, for the key, I'll do the key, but you have to ask for the key for a specific question, and then I'll help you with it. And that's how I'll do the key. Okay, any questions at all on this whole exam before we move and talk about chapter 7? Any questions? Any questions at all? Okay, if there's no questions, let's talk about new material. So we're going to put that, we're not really going to put it behind us because if you don't understand probability, you're going to have trouble finding the probabilities that we have to do now. So it is still important that you know the old material, but now we're going to focus on specific things for new material. So the first is I want to talk about sampling distributions. Okay, this class is all about taking samples and then try to understand what that sample tells us. And we've seen that we can find a mean and a standard deviation for a sample. We know how to do that. But the problem is you're not interested in the sample, you're interested in the population. And you can never get the whole population. Is that clear? Okay, in almost all situations. Population is just way too big to be able to survey everybody or take data from everything. Okay, so let me give you an example, a real life example. And it's happening at Oxford University. What is that very positive thing that's happening at Oxford University right now? Anyone following the news? And they just announced they're starting today, is what I read. No one's reading the news about Oxford University? All right, well, then I'll make you smile. It's the good news. Oxford University thinks they have a vaccine for the coronavirus. Have you heard about that? Okay, they tested it on rhesus monkeys, and the rhesus monkeys, all of them got better. Okay, I'm sorry, not got better. None of them got the coronavirus when they did things like threw a bunch of coronavirus up their nose and down their throat and in their bloodstream. And no matter what they did, they couldn't make those monkeys get coronavirus when they had the vaccine. Okay, now that's not enough to tell us that the vaccine works for people, because I'm not a monkey and you're not monkeys either. So we need to find out if it works for people. So what are they doing right now? What did they just start doing? Anyone know? It's the obvious thing. It's the obvious next step after you put it in rhesus monkeys. Yeah, they're testing humans. Why don't they just give it to everybody? I'll take the shot, right? You'll all take the shot. What's wrong? What's the problem with giving it to everyone? Yeah, side effects. What if it killed you? Okay, there's cost too. Right now, we're spending so many trillions of dollars on this thing. The cost is actually minor compared to the worry about side effects. Okay, because this virus is costing the world so much money. Almost any cost is worth it money-wise right now. But side effects, on the other hand, are a bigger worry. If you give it to everyone, and let's say it made everyone sterile, well, that would suck because the human race is over. So what you do is you do a sample. And what we're going to do is we're going to talk about samples. So you do a sample and you say, well, now what proportion of the sample got it? And now can you say that, does that tell you the whole population is going to be the same as a sample? And the answer is no. But if you do a large enough sample size, then it's going to tell you that it's very likely that the sample is similar to the population. If you do a large enough sample size and it's unbiased. Unbiased, that was chapter 1, so I don't need to talk about it again, but the large enough sample, I do. Now let me talk about the way you think about this. So instead of saying if you do a sample, consider being in the business of sampling. Okay, so now we're going to think about science. And the way science works is we want to make sure that just about every time you get it right. But once in a while you might get it wrong, and that's probably enough. But you don't want to get it, maybe once out of every million times it's wrong for something like this. But if it's right every other time, it's probably worth going for. Does that make sense? So what that means is we want to make sure of two things. One is the sample mean is the best possible estimate for the population mean. Okay, so that means it's unbiased. Okay, so any questions on that? Now, what unbiased means is it means, so let me do more of this means, that the average of all possible sample means equals the population mean. Any questions on what unbiased means? Okay, so we talked about sampling bias. Again, that's a different bias, and that's also going to make the sample mean different than the population mean. It turns out that the sample mean is an unbiased estimator. Okay, that the mean of all possible sample means is the population mean. So let me write down theorem. This is the first part of the central limit theorem. And I'm going to write this one out using symbols that are going to be hard for you to understand, but are important symbols, so we need to have them. The theorem is the following. And that is mu. Now, mu, what does mu represent? Yeah, the population mean sub one of these, this guy, x bar. What does x bar represent? You've seen this one before. What's x bar represent? Variable. Try. X bar is a sample mean. So mu sub x bar means the population mean of all possible sample means. And the theorem says that that is equal to mu. Let me make this bigger and brighter. Because it's a big theorem. This is part of the central limit theorem. Any questions on that? Okay, so one thing it tells you is that this is an unbiased estimator. That's what this theorem says. In fact, let me write this one. And this is not just theorem, but this is a central limit theorem. Not just any old theorem, but the most important theorem of all statistics. Two. Okay, two is, well, not only do we want the mean to be an unbiased estimator, but we'd like the mean to be close, the sample mean to be close to the population mean. That's a good thing. Well, the idea is we want it to not vary much from the population mean. And what do we call how much something varies from the mean? Two words I'm looking for that always go together. Kind of two of the most important words of this whole class, this whole course. Standard deviation. Okay, so the standard deviation of all possible sample means. So now let's pop that in. So that's going to be sigma sub x bar. Is equal to, turns out it's not equal to sigma. And that's a good thing. And we'll see that all the way through this quarter. It's actually equal to sigma divided by the square root of the sample size. Why is that a good thing? Why is it good that it's not sigma, that it's sigma over root n? I don't see y'all jumping in. Think about if n was 100, then we're taking the population standard deviation and dividing it by the square root of 100. What's the square root of 100, by the way? You should all know that. 10. So what we're doing is we're going to now say that our mean varies from the true population mean. Our sample mean varies from the true population mean at 1/10 the standard deviation on average. So if you have a very large sample size, that means you're going to be very likely to be really close to the population mean for your best guess. And that's what you want. You want your best guess to be a good guess. Any questions on this? Number 3. Okay, number 3 is also, all these are important, by the way. Number 3 is the following. So if the distribution of the population is normal, or if the sample size is larger than 30, then the sampling distribution is approximately normal. Only 1p, 1p, nope. Normal. Okay, where have you seen 30 before? Where have you seen larger than 30? Yeah, in your project, okay? I did that because I wanted to hammer in that number. This is for quantitative data. That was your project. When you have quantitative data, you want to have a sample size larger than 30 so that you can do analysis on it. And if you know it's normal, we can start computing probabilities. Again, for your project, you didn't do that because you didn't know how yet. But project 2, you're going to have to. Okay, and if you don't have larger than 30, you're pretty much out of luck. You can't do anything. Okay, for the yes, no question, there's going to be a whole different thing. We'll do that on Thursday, by the way. Any questions on this example? I mean, not this example, this theorem. The most important theorem of all of statistics. No question about it. Okay, what I want to do is I want to explore it a little bit. This is in the book, but it's a program I wrote, and I put it in the book. And this is discover the central limit theorem activity. Okay, so if we start, let's say we start with a skewed right distribution. Okay, and if we had, let's say n was equal to 100. So that means we're going to take samples of size 100. I'm going to click on it. And what the computer just did is it randomly grabbed 2,500 different samples, each size 100. And then it computed the mean of all the sample means. And notice that it's very close. It's almost the same, which again, it's not going to be exact because we didn't do an infinite amount, but we did 2,500 of them. The standard deviation, on the other hand, notice is not the same as the original standard deviation. The original standard deviation was 97 about, 97.67. Now we're at about 9.9. What do you notice about the standard deviation? Yeah, it's about 1/10. Okay. Okay, I could do it by scale, by the way. Okay, and it's ish again. It's ish because we are not doing an infinite number of tries. We're doing 2,500 tries of 100 each. Computers can't do an infinite. Okay. By the way, notice that you can see the standard deviation is much wider in the original than what you get out of this distribution. Do you see that? Okay. But the means turn out to be the same, about the same. Any questions at all on this in kind of looking at it? Okay, we can, if we start with a normal distribution, even if we do n equals 2, it's still pretty normal. Do you see that? But if I start out, I'm going to do my favorite distribution, which is I'm just going to play around. How about that distribution? Okay. So there's my distribution. And if I do n equals 2, it's not perfectly normal anymore. Okay. Still better. It's more normal than we started with, but it's not all that normal. Got all kinds of issues. Any questions about the central limit theorem idea? Any questions? Okay, so now what we can do is we can do an example. I'm gonna do one example and we'll call it a day. We got about 13 minutes left. Okay, so here's an example. Suppose that the number of hours per month that college students volunteer is normally distributed with a mean of 2.8 and a standard deviation of 6.7. For the following, write down the indicated distribution, sketch the diagram, answer the question, and then state whether the normality assumption was needed. Part A. If a college student is selected at random, what's the probability that that student volunteers at least 5 hours per month? Okay, so first thing, it's a key word. The very important word to be able to do this problem. And I'm going to give you the hint. It's the smallest word of the whole question. What is it? And it's really important, but it's easy to like not think about, but it's really important. Oh, smaller than A. Okay, and hopefully you know it grammar. A means we only looked at one student. Do you see that? Is that clear? If you're only looking at one student, we're not looking at a sample of a group of students. N is 1. So we're not even really talking about central limit theorem anymore. So we're only talking about not x bar anymore. We're talking about x. And I can write x tilde and 2.8 comma 6.7. It's just one, now just one student. So that means we're actually in chapter 6 now. Any questions on that? Okay, for time reasons, I'm gonna not draw the picture because that takes a while on a computer. But it's a normal distribution. Mean is 6.7. We want at least 5 hours a month. So I'm just gonna write it with P of x greater than 5. So now what we need to do is we need to grab our calculator, right? And we need to calculate these numbers. Any questions so far? Okay, so let's do that. Let's go find the calculator. I think I have it here. No, not in this one. It's in chapter 6. I believe it's that one. I'll tell you in a minute. There it is. Okay. So now if we go back, we want to be at least 5. So the low is 5. The high is a bunch of 9s. The mean was 2.8. The standard deviation was 6.7. And I hit calculate. And maybe I'll keep 4 decimals. Okay, so our probability, oops, is equal to 0.3713, about 37% chance. Was a normality assumption needed? Could we have done this if it was not normally distributed? Could we have gotten the same, could we have gotten that number? What do you think? No, we used the normal distribution calculator. Okay, so since we are just looking at an individual college student instead of a large sample, we must assume the distribution is normal. Okay, I want to mention something very important, easy to remember. What are the first 3 letters of assume? Ass, okay? Assuming is never good. You're making an ass of you and me, okay? So you want to not have to assume it. Unfortunately, for part A, we had to. Let's do part B. If 55 students are selected at random, what's the probability that they average between 3 and 4 volunteer hours per month? Okay, now the key word here is average. We're talking about a mean and not a single individual. So because of that, we're not looking at X anymore. Now we're looking at X bar. And we could say X bar tilde N the mean is going to be the same. It is still 55. I'm sorry, it's still, what was it? 2.8. That's the central limit theorem. The standard deviation, on the other hand, is not the same. That is going to be 6.7 divided by the square root of 55. Any questions on that? Okay, now I want the probability that X bar, and let's write X bar, it's a little faster, is between 3 and 4. So I can go 3 less than X bar less than 4. Okay, I need to get this 6.7 over root 55. Let's pop that into Google. And get 0.9034 is good enough. Any questions so far? Okay, we want to be between 3 and 4. So our low is 3. Our high is 4. Our mean was 2.8, so that doesn't change. And our new standard deviation is 0.9034. And let's get rid of the old probability. And I hit calculate. And you get about 0.3204. Okay, Was the normal distribution necessary? Was the assumption necessary? What do you think? Can I explain where the 6.7 came from? Oh, sorry, I had it wrong, didn't I? Oh, no, it's not right. That was given right here. Standard deviation is 6.7. Yes, that was just in the problem. And that's in the formula is sigma over root n. Okay. Okay. So was the normality assumption necessary? The answer is, since n is equal to 55, which is greater than 30, the central limit theorem, all right, CLT, guarantees that the sampling distribution is normal. So the assumption was not necessary. Any questions on that? How about find the first quartile for the average? Of 20 students. So I want to find the first quartile for the average of 20 students. So now what we do is it's very similar, but that's not going to be 55 anymore. I'm just going to copy and paste because I only have 2 minutes left. Instead of 55, it's over root 20. And then I'm going to go make that 55 a 20. And you get 1.498. So now we're going to find the first quartile. So first thing, our new standard deviation is 1.498. And now we don't know P. Our low will be 0, as oh, sorry, negative 9999. And our high, sorry, we do know P is 0.25. And our high is what we don't know. And I hit calculate. And I get about 1.7896. So the first quartile is 1.7896. Okay. Notice now, was the assumption necessary? This time, yes. The normality assumption was necessary since the sample size was 20, which is less than 31. Okay, it's now 3:25. I try to not go late. Just made it. Sorry, I had to go fast at the end. Let's stop the recording.